Hello students, very good morning. So today in this class we will discuss about the test for variances. So what is the use of this test for variances here? So till yesterday's class we have discussed about the test for means. But when there are more deviations in the data, then test for mean is not sufficient to test the hypothetical statement here. Then for that we will consider the test for variances. So in today's class we will discuss about the small sample test for variances. So when the sample size is less than or equal to 30, then to test the deviations in the observations or to test the deviations in the sample, we use the test for variances here. So we have a test for variance of a single sample and test for variance of differences of samples here. That means the test for difference of variances. So for single variance we use the chi-square test. So it is spelled as chi-square here. And for differences of variance we use the F test here. So this chi-square test and F test are partially a part of a normal distribution here. So this chi-square test carries from 0 to infinity, and even the F test is also defined from 0 to infinity here. So that's why here you can see the tendency of the graph. So here the F distribution is a right tailed here. Okay, so here you are observing the right tail. Similarly for the chi-square test also, since it is defined from 0 to infinity, so chi-square test is also here, it is symmetric only. That means it is symmetric from 0 to infinity here. So regarding the test for single variance here, the null hypothesis is given by sigma square is equal to sigma naught square. So sometimes they may ask you to test regarding the test for standard deviation. Then the null hypothesis will be sigma equal to sigma naught, where sigma square is called the population variance and sigma naught square is a specific constant. That's what we have to test here. Then again as the alternative hypothesis, it can be two-tailed, that is sigma square not equal to sigma naught square, and it can be a one-tailed also, that is sigma square either less than or greater than sigma naught square. Then under the null hypothesis, the test statistic is given by chi-square equal to n into small s square by sigma square follows a chi-square distribution with n minus 1 degrees. So here n is the sample size, small s square is the sample variance and sigma square is the population variance. Now we have to obtain the tabulated value of chi-square at n minus 1 degrees for the corresponding alternative hypothesis at a given level of significance. So where we can apply this chi-square test here? Just to test the significance of the measurements, because here we are dealing about the quantitative data, means the data which can be measured in any of the physical units. So whether the data is meeting the specific measurements or not, so there we can use this chi-square test for single variance here. Now let us see how to obtain the tabulated value here. So here the top represents the level of significance and here vertically the sample sizes are given here. So at either 0.05 or 0.01 we have to look after the table value for the corresponding sample size here. So here the sample size is given, right, and the level of significance. So the coincidence value is the tabulated value. Okay. Then next comes the difference of variances here. So for difference of variances we use the F test, which is called the Snedeker's F test. So this differences of variance was introduced by Snedeker's. So that's why it is Snedeker's F test for variances here. So to test the significant difference between the variation of the two population or between the deviation of the two populations here, the null hypothesis is given by sigma 1 square is equal to sigma 2 square. Against the alternative hypothesis, it can be a two-tailed or one-tailed. Two-tailed means here sigma 1 square not equal to sigma 2 square, and one-tailed means sigma 1 square less than sigma 2 square or sigma 1 square greater than sigma 2 square. Then under the null hypothesis here we have two cases. So first we have to find out the capital S1 square and capital S2 square, which are given by the formula here, capital S1 square as 1 by n1 minus 1 summation x1 minus x1 bar whole square, where the summation x1 minus x1 bar whole square is also known as the sum of square of deviation from the means. And similarly we have to obtain the capital S2 square as 1 by n2 minus 1 summation of x2 minus x2 bar whole square. Now whichever is having the greater variance, that will be there in the numerator and the lesser variance in the denominator. So that's why here we have f equal to capital S1 square by capital S2 square, provided capital S1 square is greater than capital S2 square. So when you are considering the test statistic as f equal to S1 square by S2 square, we have to obtain the tabulated value at n1 minus 1 comma n2 minus 1. Now how to obtain the tabulated values we will see in the next slide here. But when capital S2 square is greater than capital S1 square, then the test statistic is given by capital F equal to S2 square by S1 square follows a F distribution with n2 minus 1 comma n1 minus 1. Then again the F calculated value, if less than the tabulated value at a given level of significance, then H0 is accepted, otherwise H0 is rejected. Now one more important thing we have to notice here, that always the calculated value for the single variance or difference of variance is positive. Means it cannot be negative here, and no need to consider the modulus, because variance is nothing but sum of square of deviation from the means. So variance cannot be negative here. So always variance is positive. So the calculated value for chi square and as well as for f should be positive only. There is no question of negative here. Now we can obtain the tabulated values of f. Here the top one represents the n1 minus 1, okay, and here vertically it is n2 minus 1, because we are having two samples. So top one represents the n1 minus 1, which is called v1, and here vertically this is n2 minus 1, which is called v2 here, okay. Then the coincidence value, so for suppose here the sample size is here 10 for n1 and 9 for n2 here. Then 10 minus 1 is 9 and 9 minus 1 is 8. So at 9 comma 8 we have to look after the table value. So that coincidence value is your F tabulated value. Then the conclusion is same. Just now we have discussed about the test statistic for single variance and difference of variance. So first we will go through the problems on single variance here. So if you move on to the problem, a random sample of size 20 from a normal population gives a mean of 42 and a variance of 25. Test the hypothesis that the population standard deviation is 8 at 5% level of significance, and the tabulated value of chi square for 19 degrees is given as here 30.144. Now if we move on to the solution here, so here the hypothesis may be of standard deviation or maybe of variance. So whatever they will ask in a question, so that hypothesis we have to frame here. Now in this question they have asked to test the hypothesis that the population standard deviation is 8. So we have to frame the hypothesis regarding standard deviation. So as we know that here the null hypothesis is an unbiased statement. So always sigma is equal to 8. Right? Then against the alternative hypothesis, there are no comparable words in the question. So it is sigma not equals to 8 here. Then under the null hypothesis, the test statistic is given as here chi square equal to n into small s square by sigma square follows a chi square distribution with n minus 1 degrees. Now n is the sample size, that is given as here 20, and small s square is the sample variance. So a random sample of size 20 from a normal population gives a mean of 42. Actually here for the test for variance, there is no need to calculate the mean here. But sometimes to make you confused, they will give the excess data here. Right? So here the sample mean means x bar is 42. But even though we have to write the given data here, and a variance of 25, that means the sample variance is 25. Now sigma square means the population variance. So here they have given the population standard deviation. Now square of this will gives you the population variance. So that is 8 square is 64. Now let us substitute this data in the calculated formula. So chi square equal to n into s square means 20 into 25 by sigma square 64. So here the chi square calculated value will be 20 into 25 divided by 64 is 7.8125. Now remember here always the chi square calculated value Means the test statistic for variance will be always positive only, because variance is nothing but sum of square of deviation from the means. So here variance cannot be negative, so variance is always positive only. So here the test statistic for the variance, whether it is single or difference of variance, always the calculated value will be positive. So there is no question of negative here and considering the modulus of it. Now, if you see the tabulated value, chi-square tabulated value at n minus 1, that means 20 minus 1 is equal to 19. For here the alternative hypothesis is not equal to, so for 2 type, at level of significance is given as here 5%. So at 5% level of significance is 30.144. Now the chi-square calculated value is 7.8125 and tabulated value is 30.144. So that means chi-square calculated value is less than chi-square tabulated. So therefore H0 is accepted. H0 is accepted means here the population standard deviation is equal to 8 here. So they asked you to test whether the population standard deviation is equal to 8 or not. So here H0 is accepted. That means the population standard deviation is 8. So that is the test for single variance. Now let us see one more problem on this. A firm manufacturing rivets wants to limit variations in their length as much as possible. The lengths, which are measured in centimeters, of 10 rivets manufactured by a new process are 2.15, 1.99, 2.05, 2.12, 2.17, 2.01, 1.98, 2.03, 2.25 and 1.93. Examine whether the new process can be considered superior to the old if this old population has a standard deviation 0.145 centimeters and the tabulated value for chi-square at 9 degrees is 16.919 here. Okay. So here, now this time the individual observations are given to us. So the sample variance is not given directly. So using these observations, we have to obtain the sample variance using the calculator under regression linear mode. So first we have to frame the hypothesis. So H0 here. So here they want to limit variations in their length. So they are asking about the variation. So here we have to take the hypothesis of variance, not for standard deviation. Of course, standard deviation is nothing but square root of variance only. So sigma square is equal to the population variance is standard deviation is given as 0.145 centimeters. That means here 0.145 square, which is equal to 0.0210. Okay, so null hypothesis we have to test for sigma square equal to 0.0210. Now again is the alternative hypothesis. Now here in this question they have used a comparable word, that is the new process can be considered superior to the old. Means here the old process is having a lesser means the variation for the new process is superior compared to the old one here. That means here the alternative hypothesis is sigma square greater than 0.0210. Okay. Then under the null hypothesis, the test statistic is given as n into small s square by sigma square follows chi-square with n minus 1 degrees. Now here n means the sample size is given as here 10. And sigma square, so just now we have obtained the square of deviation, that is 0.0210. Now here we know that the sample variance formula is 1 by n summation x square minus x bar square here. Okay. Now we have to use the calculator for obtaining this small s square. So go to the regression linear mode and one by one read these observations. So the first observation is here 2.15, then 1.99, then 2.05, then 2.12, then 2.17, then 2.01, then 1.98, 2.03, 2.25, 1.93. So all the 10 observations are stored in the calci. Now next go to the shift 1, then summation x square. So that is given by 42.8572. Now directly we can obtain the value of x bar, that is shift 2 first option is here 2.068. Now the small s square also can be obtained using calculator, that is shift 2 second option is here small s, but we want the square of that, so make a square of that, so it is 0.0091. Now substitute in the test statistic. So n into small s square, that means 10 into 0.0011 by sigma square is here 0.021. So that means chi square calculated is here 10 into 0.0091 divided by 0.021 is here 4.3333. Okay. Now chi square calculated is 4.3333. Now chi square tabulated at 10 minus 1 means 9 degrees for one tile at 5%. Here the level of significance is not mentioned. So by default we have to consider 5%. So at 5% level of significance is here 16.919. So chi square calculated is 4.3333 and chi square tabulated is 16.919. So that means chi square calculated is less than chi square tabulated. So therefore H naught is accepted. H naught is accepted means here the sigma square is equal to 0.021. That means here we are rejecting the alternative hypothesis. That means the superior means the new process is superior to the old. We are rejecting it. So the conclusion for this problem is here sigma square is equal to 0.0210 centimeters. So that's about the test statistic for single variance. Okay. But here when we are considering two samples and then we have to test regarding the two deviations or two variations, then we have to use the F test for differences of means here. So let us move on to the F test. Let us see the problems on test for difference of means here. In one sample of 8 observations from a normal population, the sum of squares of deviation of the sample values from the sample mean is 84.4, and in another sample of 10 observations, it was 102.6. Test at 5% level of significance, LOS means level of significance, whether the population have the same variance. Now the tabulated value of F for 7,9 degrees for 5% is given as here 3.29. So here the two samples they have given, and clearly in the question test whether the population have same variance they have asked. So the problem is regarding test for difference of variances. So H naught is here sigma 1 square equal to sigma 2 square. That means the variance of the two populations are equal. Then against H1 there are no comparable words here. So our H1 is 2 times, that is sigma 1 square is not equal to sigma 2 square. Then under H naught here, actually the test statistic is based on the capital S1 square and capital S2 square. So first we have to obtain the values of capital S1 square and capital S2 square. So the first sample size is 8, that means N1 is equal to 8 and the second sample size is 10 observations. So N2 equal to 10. Now the sum of square of deviation from the sample values is given as here 84.4. So that means the summation of x1 minus x1 bar square is 84.4 and summation of x2 minus x2 bar square is here 102.6. Now we know that the capital S1 square formula is here 1 by n1 minus 1 summation of x1 minus x1 bar square. That means 84.4 by n1 minus 1 means 8 minus 1. So 84.4 divided by 8 minus 1 is here 7. So that is 12.0571. Okay. Then capital S2 square formula is here 1 by n2 minus 1 summation of x2 minus x2 bar square. So that means here 102.6 by n2 is here 10. So 10 minus 1. So that is here 102.6 divided by 9 is 11.4. Now whichever is having the greater variance, that will be there in the numerator and lesser variance in the denominator. Now if we compare here, capital S1 square is 12.0571 and capital S2 square is 11.4. So our F statistic is capital S1 square by capital S2 square follows F distribution with n1 minus 1 comma n2 minus 1. So that means F equal to here 12.0571 by 11.4. So F calculated value is here 12.0571 divided by 11.4 is here 1.0576. Now the tabulated value of F at n1 minus 1 comma n2 minus 1 means 8 minus 1 comma 10 minus 1, which is equal to 7 comma 9, right, at 5% level of significance, is here given as 3.29. So that means here F cal is 1.0576. So F cal is less than F cal. So H0 is accepted. That means here sigma 1 square is equal to sigma 2 square. So there is no significant difference between the two population variances. So that is the conclusion for this problem. Let us see one more problem on this. Pumpkins were grown under two experimental conditions. Two random samples of 11 and 9 show the sample standard deviation of their weights as 0.8 and 0.5. Assuming that the weights distribution are normal, test hypothesis that the variances are equal, and the tabulated value of F for 10,8 is given as 3.35 here. Okay. So the H0 will be, the question is very direct, test hypothesis that the variances are equal. So sigma 1 square is equal to sigma 2 square. Again, as the alternative hypothesis is here, it is 2 tile only because there are no comparable words. So sigma 1 square is not equal to sigma 2 square. Then under the null hypothesis, first we have to write down the given data. So the first sample n1 is here 11 and n2 is here 9. And their standard deviations are given. That means here directly they have given the small s1 as 0.8 and small s2 as 0.5. Okay. Now using this small s1 and small s2, we have to obtain the values of capital S1 square and capital S2 square. So we have a relation between the capital S1 square and small s1 square. That is nothing but capital S1 square equal to n into small s1 square by n minus 1. So here we are considering two samples. So n1 into small s1 square by n1 minus 1. So that means here 11 into s1 square means 0.8 square by n1 minus 1. So 11 minus 1. So if we simplify this here, 11 into 0.8 square divided by 11 minus 1 is 10. So it is here 0.704. Similarly, we have to calculate the capital S2 square as n2 into small s2 square by n2 minus 1. So that means n2 means here the sample size is 9. So 9 into s2 is here 0.5. So 9 into 0.5 square by 9 minus 1. So it is here 0.2813. So capital S1 square is 0.704 and capital S2 square is 0.2813. So again the test statistic is here capital S1 square by capital S2 square follows the F distribution with n1 minus 1 comma n2 minus 1. So here F calculated will be 0.704 by 0.2812. So that is equal to here 2.5027. So that means the F calculated value is 2.5027 and F tabulated value at here S1 square by S2 square. So we have to obtain it n1 minus 1 comma n2 minus 1, which is nothing but 11 minus 1 comma 9 minus 1 means here 8. So at 11 minus 1 comma 9 minus 1 is 10 comma 8 for 5% level of significance. So here level of significance is not mentioned, so consider 5%. So it is the tabulated value is here 3.35. So F calculated value is 2.5027 and tabulated value is 3.35. That means F calculated value is less than F tabulated, so therefore H0 is accepted. That means there is no significant difference between the two population variances. So sigma 1 square is equal to sigma 2 square. So time taken by the workers in performing a job by method 1 and method 2 is given below. So by using method 1, 20, 16, 26, 27, 23, 22. And regarding method 2, 27, 33, 42, 35, 32, 34 and 38. Do the data show that the variance of time distribution from population from which these samples are drawn do not differ significantly, and the tabulated value of F for 5,6 is given as here 4.39. Now here regarding the first method 1, 2, 3, 4, 5, 6 observations are there, and regarding the method 2 we have 7 observations. So here I have taken a blank because here at a time if you give the two methods in the calci, it will take the first sample size as here 7. So that's why here I have definitely given the blank. Okay. Now come to the solution here. So the null hypothesis will be sigma 1 square is equal to sigma 2 square. The question is very direct here. Do these data show that the variances of time distribution? So it is a test for variances. Then against the alternative hypothesis, there are no comparable words, so it is two-tailed, that is sigma 1 square not equal to sigma 2 square. Then under the null hypothesis, so first here we have to obtain the values of capital S1 square and capital S2 square here. So regarding the first sample N1, the size is here 6 and second sample is here, the size is here 7. Okay. Now we have to obtain the values of capital S1 square and capital S2 square. So we know the formula for capital S1 square as 1 by n1 minus 1 summation of x1 minus x1 bar whole square. So instead of using this x1 bar here, directly we can obtain the value of capital S1 square using calci under regression linear mode. So first go to the regression linear mode and one by one give the values of method 1 here. So 20 m plus, 16 m plus, 26 m plus, 27 m plus, 23 m plus and 22 m plus. Okay. Now press shift 2. The third option represents the capital S here. So press the third option and equal to, here you are getting capital S, but we want the square of that. So press the square. So it is here 16.2667. So capital S1 square is 16.2667. Directly when the observations are given, we can use the calci to obtain capital S1 square. Now coming to S2 square here, the formula is 1 by n2 minus 1 summation of x2 minus x2 bar square. Now whatever the data we have given for method 1, that data we have to erase. That means we have to clear the memory here. And again go to the regression linear mode, then give the data. Because if we do not clear the data here, then obviously it will take the 7th observation as method 2 here. Okay. So that's why for the method 1, after the calculation is completed, you have to erase the data here. Now see the method 2, the first observation is 27. 27m plus, then 33m plus, 42m plus, 35m plus, 32m plus, 34m plus and 38m plus. So all the 7 observations are stored. Now press shift 2 and here third option for capital S. So it is here 4.7208. Now we have to make a square of that. So it is 22.2857. So capital S2 square is 22.2857. Now the F statistic will be here. Whichever is having the greater variance, that will be there in the numerator. So S1 square is 16.2667 and S2 square is 22.2857. That means here capital F equal to S2 square by S1 square. So it is 22.2857 by 16.2667. So F cal value will be here 22.2857 divided by 16.2667. So it is here 1.37. We have to obtain the tabulated value at 6, 5 here. So at 6, 5 the tabulated value is 4.95. Because the test statistic is here F equal to S2 square by S1 square follows F distribution with N2 minus 1, N1 minus 1. N2 is here 7 and N1 is 6 here. So F tabulated at 7 minus 1, 6 minus 1, that is 6, 5 at 5% level of significance is here 4.95. So F cal is 1.37 and F tab is 4.95. That means F cal is less than F tab. So therefore H naught is accepted. H naught is accepted means here sigma 1 square is equal to sigma 2 square. That means here the variances of time distribution does not differ significantly. So that is the conclusion for this problem here. So that's about the problems on differences of variances. Now in the next class we will discuss about the qualitative data, that is the chi-square distribution.